Hi everybody, this is Eduardo Suarez. This video is part 5 of a series of videos dedicated to iRPickTool. In part 4, we continued creating a workcell using Roboguide HandlingTool. We continue setting up the iRPickTool workcell following the steps on the workflow. We set up the iRPickTool objects for the workcell. We set up the gripper. We set up the robots. In our case, we don't have a tray, but if you have a tray, you need to set it up too. We set it up the conveyors and the conveyor stations on the Infeed and Outfeed, and also the operation conveyor station on the robot. And finally, we set up the tracking frame, and I show you a way to verify the tracking frame data. On this video, we're going to continue with the iRPickTool setup following the steps on the workflow. The next step is going to be setting up the Infeed sensor. We're going to consider the trigger condition is going to be distance, and the trigger action is going to be find part by vision. We're going to perform the camera setup. We're going to perform the camera calibration. We're going to create the vision process. After that, we're going to set up the sensor on the iRPickTool setup screen, and we're going to teach the sensor reference position. We're going to go back to the workcell, and we're going to place the calibration grid on the Infeed conveyor. We're going to create a new part that's going to be the calibration grid, and we're going to select the Infeed conveyor. We're going to go to part carrier Infeed. We're going to go to properties. We're going to go to part. We're going to select the part, and we're going to edit the part offset. We're going to verify that the X direction for the calibration grid is the same as the X direction for the Infeed conveyor, and also we're going to verify the spacing on the calibration grid. For that, we're going to take a measurement tool, and we're going to measure the distance between two dots. And we have 15 millimeters. Now we're going to add the camera. We're going to select the sensor unit. We're going to add a vision sensor unit, and we're going to select the add to the camera, and we're going to select the CAD library. From the CAD library, we're going to select the camera black and white, and we're going to press OK. By default, Roboguide places a camera on this position, so we're going to change that position. We're going to select the sensor unit. We're going to right click, and we're going to go to properties, and we're going to change the location. And we're going to apply. Now we have the camera on this new location. Now we're going to select the camera. We're going to go to properties. We're going to select the setting tab. We're going to set the focus length to 12 millimeters. We're going to go to the view tab, and we're going to change the height to 485 millimeters. And we're going to press OK. One more thing that you can do is also change the orientation of the camera in such a way that the longer distance of the field of view is aligned with the travel distance of the Infeed conveyor. We're going to select the robot controller number 1. We're going to expand. We're going to select the vision. We're going to right click, and we're going to enable the vision simulation. After rebooting, we're going to select the vision again. We're going to go to Properties. We're going to select the General tab. We're going to select the port. And we're going to select the Sensor Unit Camera 1. And we're going to press Apply. And with this, we have the camera connected to robot controller number 1. One important thing is that you want to have the camera connected to the same robot that has the encoder for the Infeed conveyor. In this way, the camera data for the part position is going to be more accurate. This is only one possible configuration for the camera. You can have more than one camera. For example, you can have one camera connected to each robot controller. You have one camera upstream robot controller number 1, and you have the other camera upstream the robot controller number 2. But in the case, you connect the camera to each individual robot controller. Otherwise, the processing data for one robot controller is going to be too much. One of the reasons you might want to consider using more than one camera is when the part can move in any direction while it's traveling along the conveyor. We're going to continue now setting up the camera. We're going to select Robot. We're going to select Internet Explorer. We're going to select IR Vision. And we're going to select IR Vision Setup. If you have a computer, you can also access this screen in the same way that we did for the iRPickTool setup. You just connect to the robot ring and you type the IP address for the robot. On the IR Vision Setup screen, we're going to create a new vision data. We're going to give it a name. And we're going to press OK. We're going to select camera 1 and we're going to press Edit. We're going to select Advanced Mode. This is going to give us a few more options for the setup. And over here we have the camera setup. So for camera, we're going to select the camera that we have on the workcell, immediately showing us what it is on the camera. For robot mounted camera, we're going to select No. And if you have your real camera, you need to set it up the exposure time, the focus, and anything else. For calibration, we're going to select camera calibration for 2D vision tracking. And with this, we have a green check mark on the camera setup. Now we're going to select calibration. For conveyor name, we're going to select the Infeed conveyor. Grid spacing, we know already that the calibration grid is 50 millimeters. Projection, we're going to select perspective. Camera distance, we're going to override the focal distance. And we know already that the focal distance is 12 millimeters. We're going to take a snap and we're going to select calibration guide. In this case, it says this guide leads you to calibrate the camera. If you can see the grid pattern on the screen, click OK. Now we're going to close the window. We're going to press OK. And the origin point, move the conveyor until the fixture is in the robot working envelope. And stop the conveyor, jog the robot so that the TCP touches the origin point, and click OK. So for that, we need to go back to the workcell. On the workcell, we're going to select the robot controller number 1. We're going to make the working envelope visible. and we're going to select the teach pendant. On the teach pendant, we're going to change the coordinates to world, and also we're going to make sure that we're using the user tool number 9, that is a pointer. We're going to open up the conveyor control. We're going to select the Infeed conveyor. We're going to change the speed, and we're going to move the calibration grid until it's inside the working envelope for robot controller number 1. Once we have the part inside the working envelope for robot 1, we're going to stop the conveyor, and we're going to move the robot to touch the origin for the calibration grid. Once we have the TCP on the origin of the calibration grid, we're going to go back to the vision setup, and now we're going to press OK. Now we're going to move in the X direction. Without moving the conveyor, jog the robot so that the TCP touches the X axis direction point, and click OK. So for that, we just need to move the robot we're going to move the robot on the X direction. We're going to go back to the vision setup screen, and we're going to press OK. Now on the Y-axis direction point, without moving the conveyor, jog the robot so that the TCP touches the Y-axis direction point, and click OK. So now we need to move on the Y direction. And we're going to press OK. So now it says the calibration standoff distance is 487 millimeters, and we're going to press OK. The calibration data was calculated. The calibration guide has completed. And with this, we can save. We have the camera set up, we have the calibration, we have the calibration point, and the calibration result. We can see here all the points for the calibration. And this is going to be the position of the calibration grid relative to the tracking frame. Now we can exit the vision setup editor. For the next step on the workflow, that is configuring the vision process, we're going to remove the calibration grid for the Infeed conveyor. We're going to add a new part, and we're going to create a vision process. We're going to go back to the workcell. We're going to select part. We're going to add a new part, and we're going to add a box. We're going to edit the box. And we're going to press apply. Now we're going to go to the Infeed conveyor. We're going to select the part carrier Infeed. We're going to go to parts. We're going to remove the calibration grid, and we're going to add a part. We're going to edit the position for the part, and this is going to be 10 millimeters on the Z. And now we have the part on the Infeed conveyor. We're going to go to the iRPickTool setup screen, and we're going to create a vision process. That's going to be the 2D single view visual tracking. We're going to give it a name, single view vision tracking, and we're going to press OK. We're going to select the vision process and we're going to press edit. On the right hand side, on the parent tool, we're going to select the camera. That's going to be camera 1. You can see now that if we do a snap, we can find the part. And the other thing that we can do is edit the color of the part. We're going to go back to the workcell. We're going to select the part. And we're going to change the color to something that is going to be a bigger contrast. So we can select, for example, white. Now, if we take another snapshot, it's going to have a better contrast on the background for the Infeed conveyor. So we're not going to make any more changes over here. We're going to select the snap tool. In your real camera, you can make changes to this. You can adjust the exposure time. If you have lighting, you can adjust that too. We're not going to make any changes. We're going to go to the GPM locator tool, and we're going to teach the GPM. We're going to select teach. We're going to select the part. We're going to press OK. We're going to set the origin. Something like that. We're not going to make any more changes unless that is required. And we're going to press find. And you can see that we can find the part and we have a 100% score. Now we're going to select the offset data calculation tool. We're going to set the Z height. That's going to be 10 millimeters. We're going to press find, and we're going to press set for the reference position. You're going to have this message: trigger has been set. Please teach a handling point for robots which handle this part. We're going to press OK. We're going to press save, and we can end the edit. With this, we have created a vision process. The next step is going to be setting up the sensor and teaching the sensor reference position. We're going to go to the iRPickTool setup. We're going to select the Infeed object, and we're going to select the sensor. On the setup, we're going to select for controller, robot number 1. For the trigger condition, we're going to select distance. And for the trigger action, we're going to select find part by vision. We're going to select the vision process. It's going to be the single view vision tracking. One more thing we need to do, since we specified the trigger condition as distance, we need to specify the trigger distance. That means how many millimeters apart the vision system is going to be triggered as the Infeed conveyor moves. For that, there is a formula, and the formula for the trigger distance is the field of view minus the length of the part divided by 2. The idea here is that you want to trigger the vision system seeing the same part at least 2 times. We're going to go back to the workcell. We're going to measure the field of view. We're going to use the measurement tool. And we have 273 millimeters. we want to recalculate the formula. So it's going to be 270 millimeters for the field of view, minus 15, that is the length of the part. That's going to give us 220 millimeters, divided by 2 is 110 millimeters. We're going to go to the sensor, and we're going to change this to 210 millimeters. Now we need to set the reference position. For that, we're going to select in here, set the reference position. And this is going to be a wizard again. This says, this guide leads you so that you can set up the reference position. Please put a target in the field of view. Press find when ready. When the target is found successfully, the reference position is set. So we have the part on the field of view of the camera, and we're going to press find. The part was found, and this is the coordinates. We're going to press next. This is the second page on the reference position guide. It says, after you press finish, jog the conveyor so that the target comes in front of the most upstream robot, which is the closest to the sensor, and teach the robot position in TP program from that robot in order. So now we're going to press finish. We're going to go back to the workcell. We're going to select the robot number 1. We're going to make the working envelope visible, and we're going to open the teach pendant. For this part, we need to select the tool frame number 1. We're going to change the coordinates to world, and we're going to change the tool to number 1. And now we have the suction cap. We're going to confirm that this is a tool selected. Now, if we follow what the second page of the guide was saying, without moving the position of the part, we need to jog the Infeed conveyor until the part is inside the working envelope for the robot, and we need to touch the part. We're going to open the conveyor control. We're going to select the Infeed conveyor. We're going to change the speed, and we're going to jog the Infeed conveyor forward. We want to stop the part on the most upstream position. We're going to open up the teach pendant again. Now we're going to press select. We're going to split the skin. And we're going to look for a TP program that is called PK_CB_PIC11. This is the program we are looking for. We're going to press enter. And we're going to go to line number 17, where we have the position register 57. We're going to move the robot so that the TCP touches the part. Once we have the TCP on the part, we're going to select the line 17. We're going to press Shift, and we're going to press Touch Up. It's going to say the vision register 1 is uninitialized continua. We're going to press yes, and the position has been recorded to position register 57. What we can do now, on the second half of the screen, we can select data, we can select position register, and we can go to position register 57. We're going to select the position register 57 and we're going to press position. We're going to write down these values, and now we're going to select the robot controller number 2, and for the position register 57 on robot number 2, we're going to copy these values. We're going to select the robot number 2, we're going to select position register, we're going to select position register 57, we're going to select position, and we're going to copy the values that we have from the robot number 1. Once we set the values for the position register, we're going to press done. We're going to go back to the workflow, and with this we finish with step number 5, setting up the Infeed sensor. The next step is going to be setting up the Outfeed sensor. We're going to consider that the trigger condition is going to be distance, and the trigger action is going to be put button Q. Selecting the trigger condition as distance can be very convenient when you're doing simulations and you don't have a sensor to trigger, and putting the button Q will allow the part to be placed on the conveyor at regular intervals. We're going to go back to the workcell. We're going to select the Outfeed conveyor, and we're going to select part carrier Outfeed. We're going to select the part tab, and we're going to make the part visible. And also we're going to teach the position. We're going to go to the iRPickTool setup screen. We're going to select Outfeed, and we're going to select the sensor. On the settings, we're going to select the controller. We're going to select Robot 1. The trigger condition is going to be distance, and the trigger action is going to be button Q. For trigger distance, we're going to select 100 millimeters. So the part is 50 millimeters in length, so we're going to have one part length between two parts. Now you're going to notice that the target position is blank and the reference position is not trained. So for that, we're going to train the target position and the trigger position at the same time. We're going to go to set trigger position, and we're going to have another guide again. This guide leads you so you can set up the target position and reference position. Please put a target on the conveyor stream where you want to generate the targets. Press set trigger when ready, then jog the conveyor so that the target comes in front of the most upstream robot. So we have the part ready on the conveyor. We're going to press set trigger, and now we need to jog the conveyor so that the target comes in front of the most upstream robot. So in our case again, if we look at the product flow for the Outfeed conveyor, it's running in parallel to the Infeed conveyor, and the most upstream robot is going to be Robot 1. In the case of the counter flow, you're going to be running in the opposite direction, and you're going to have Robot 2 as the most upstream robot. We're going to select the Robot 1, and we're going to make the working envelope visible. And now we need to jog the Outfeed conveyor until the part is inside the working envelope for the robot. We're going to select the Outfeed conveyor. We're going to change the speed, and we're going to run it forward. Once we have the part inside the working envelope for the robot number 1, we're going to touch the part with the TCP. For that, we have to make sure that we're using the user tool number 1. We're going to open the teach pendant, and we're going to verify that we have the user tool number 1 selected. We're going to go back to the iRPickTool setup screen, and we're going to press next. So now it says, please teach the robot position and TP program from the most upstream robot in order. Press record, we're ready. After you press finish, please teach the robot position and TP program. So what we need to do now, we need to touch the part with the TCP. When we're touching the part, we're going to go back to the iRPickTool setup, and we're going to press record. We're going to have the encoder count, the top position, and the calculated position. Now we're going to press finished, and with this we have a green check mark on the sensor, and the reference position have been trained. We're going to go back to the workcell. Without moving the part, we're going to open the teach pendant, and this time we're going to look for a program that is called PK_CV_drop11. We're going to press enter. We're going to go to line 69, and we're going to touch up the position register 59. So for that, with the TCP touching the part, we're going to press shift and touch up. It's going to say the vision register number 2 is uninitialized continuing. We're going to press yes. And with this, we have the position have been recorded to position register 59. We're going to split the screens. On the right hand side, we're going to select data. We're going to select position register. And we're going to go to position register 59. We're going to press position, and we're going to write down the position that we have in here, and we need to copy this value to the same position register on robot number 2. So now the process is similar to what we did for position register 57. We're going to select the robot controller number 2. We're going to select data, position register, position register 59. We're going to select position, and we're going to copy the data over here. And when we finish copying the data, we're going to press done. And with this, we finish with step number 6, that is setting up the Outfeed sensor, setting up the sensor, and teaching the sensor reference position. The next step is going to be setting up the upstream and upstream boundaries on both robots for the infeed and outfeed conveyors. We're going to go back to the iRPickTool setup screen. We're going to select the infeed conveyor and we're going to go to conveyor station number 1. The process is going to be exactly the same for all the robots, so I'm just going to show you how to do that on one conveyor station and one robot, and it's going to be exactly the same on all the conveyor stations. We are on the conveyor station number 1. We're going to set up the upstream boundary. For that, we're going to go back to the workcell. We're going to select the robot number 1. We're going to make the working envelope visible, and we're going to move the robot to the most upstream position. We're going to move the infeed conveyor, and we're going to place the part in such a way that the trailing edge of the part is touching the TCP. From this position, we're going to move the TCP one length of the part to the leading edge. We're going to go back to the iRPickTool setup screen and we're going to press record. For the downstream boundary, we're going to move the robot to the most downstream position. We're going to move the part and we're going to position the part with the leading edge touching the TCP, and from that position we're going to move back the robot one length of the part. And for this position we're going to go back to the iRPickTool setup screen and we're going to record the downstream boundary. For the discard line, the rule of thumb is that you're going to select 2 lengths of the part. So in our case, it's going to be 100 millimeters. And this is going to be the discard line from the downstream boundary. You're going to see now we have a green check mark on the conveyor station number 1. We're going to select conveyor station number 2. And we're going to repeat the same process on conveyor station number 2, conveyor station number 3, and conveyor station number 4. Once you have the upstream and upstream boundary set up, you will have a green check mark on all the conveyor stations. You can also go back and change the boundaries if you notice that you're getting a track destination gone on the robots. One thing to notice is that you are always looking at the direction of the product flow. So in our case, the product flow goes from left to right in both conveyors, and the upstream boundary is going to be on the left and the downstream boundary is going to be on the right. We're going to go back to the workflow, and the next step is going to be teaching up the perch position. For the perch position, we're going to move the robot to the position that we want to select as a perch. We're going to open the teach pendant. We're going to select the TP program that's called PK_main1. We're going to press enter. We're going to put it in step mode, and we're going to run the program in step mode until we get to the program that's called PK_perch1. Now we are in the PK_perch1. We're going to step forward until we get to line number 15 when we have the position number 1. When we are in this position, we're going to teach this position number 1. So we're going to press Shift and touch up. And we have the position has been recorded for position number 1. And also we're going to repeat the same process for row number 2. Once we have taught the perch position for both robots, the final step is going to be testing the system. We're going to go back to the work cell, and before we put the system in runtime, we're going to make a quick check. We're going to select the Infeed conveyor. We're going to select the part carrier Infeed. We're going to go to properties. We're going to select the conveyor, and we're going to change the destroy distance to 4,000 millimeters. That's going to be approximately over here. We're going to look at the rate. This is the rate, is a part per minute. We're going to select 60 part per minute. That's going to give us 1 part per second. And in here you have a timetable where you can select the timing and change the rate if you want. So this is going to be the time. It's going to be in seconds. So every 1 second is going to be updating line number 1. If you want to change the rate, let's say you want to run 60 part per minute for 10 seconds, and then you want to increase or decrease, let's say to 50 part per minute, you can put a line number 2 that's going to be 50 part per minute, and you can select the timing that is going to be running at that rate, and then it's going to go back to line number 1. The conveyor speed is going to be 200 millimeters per second. So at this rate and this speed, we're going to have 1 part per second, and the parts are going to be 200 millimeters apart. We're going to select the part tab, and we're going to select visible and runtime. We're going to do the same on the Outfeed conveyor. We're going to go to properties. For the part, we're now going to check visible runtime. And if we go to the conveyor, we're going to put the destroy distance to 4,000 millimeters, and we're going to apply the same rate and the same speed. We're going to select the robot controller number 1. We're going to open the teach pendant. We're going to select the TP program PK_main1, and we're going to put the teach pendant in off mode, and we're going to do the same on robot controller number 2. We're going to select PK_main1, and we're going to put it in off mode. We're going to make a few more adjustments. We're going to go to the iRPickTool setup screen. On the work cell, we're going to enable the dynamic load balance, and on the operation station for Robo 1 and Robo 2, we're going to enable the weight position. We're going to select our vision. We're going to select the vision configuration, and we're going to uncheck the disable runtime display. Then we're going to go to our vision runtime. You can see here the vision system that is in the part. We're going to go back to the work cell. We're going to select test run on the menu, and we're going to open the run panel. We're going to check the synchronized time, and we're going to move the slider to the right. And also for the runtime refresh rate, we're going to move the slider to the right to smooth out the graphics. And now we can press the run. You're going to see that the robots are waiting on the weight position, and robot number 1 is waiting for the part to arrive on the upstream boundary. Robot number 1 starts to pick and place, And now robot number 2 is going to be waiting for the part to get on the upstream boundary too. I'm not going to spend time showing you how to do the simulation. We just prove that the system ran. We can open the Vision runtime, and you're going to see the part in runtime on the Vision system, and it's detecting each one of the parts. When I was editing the video, I noticed I made a mistake. So we're going to go back to the iRPickTool setup screen. We're going to select the sensor on the Infeed, and we're going to change the trigger distance to 110 millimeters. And for the Outfeed sensor, we're going to put the trigger distance to 200 millimeters. And now we're going to run the system again. You're going to notice that the robot is placing the part every 200 millimeters. That's more correct. And now we shouldn't be missing any parts on the Vision system. You can see on the Vision that it's see the part at least one time. And we're triggering every 110 millimeters. We can also see the production status if we go to the iRPickTool and we select the iRPickTool workcell production status. You're going to see this screen where you have the Infeed, and on Infeed is showing you the conveyor speed, the total number of pick counts, and the total number of miss counts. If we look at the sensor number 1, it's going to show you relevant information. And if we look at the conveyor station number 1, the pick count is going to be 59. The pick rate is going to be 29 part per minute. That's half of what we have right now. We have 60 part per minute, and we're doing load balance, so this number is right. And if we look at the conveyor station number 2, the pick rate is 27.4 part per minute. So this is some relevant information that you have to look at when you are in production. Let's go back to the iRPickTool setup workflow. The objectives of this video was to show you how to set up iRPickTool on a real system. If we recap, on part 2 of this video, we did the initial setup of the workcell. We added the robots, the Infeed and Outfeed conveyors. We added the 2 user tools. One is a pointer that we use for teaching the points on the tracking frame, and the second user tool is a gripper, in our case a suction cap, that we used for picking and placing the parts. Finally, we configure the IP addresses on the robots. On video number 3, we continue with the configuration. Once we have the IP addresses on the robots, we set up the robot ring using RIPE, and then we configure encoders for the Infeed and Outfeed conveyors on both robots. On video number 4, we started to get into the iRPickTool setup configuration. On the tree view, we set up the objects in order starting from the workcell, then the grippers, the conveyor with the conveyor stations, and the operation stations on the robots, And finally, we set up the tracking frame for the Infeed and the Outfeed conveyors. On this video, that is part number 5, we set up the sensors. For the Infeed conveyor sensor, we consider the trigger condition at distance and the trigger action as find part by vision. For the Outfeed conveyor sensor, we consider the trigger condition at distance and the trigger action as put button Q. Also, we set up the sensor reference position and the vision tracking frame. After setting up the sensors, we set up the upstream and downstream boundaries on the conveyor station. We taught the robot perch position, and with this, we completed the setup of the iRPickTool. Once we start testing the system, we are not done yet with our job. We need to start doing the fine adjustment of the system. We need to go back to our iRPickTool setup screen and find all the little things that we need to optimize, such as adjusting the boundaries on the conveyor stations, adjusting the conveyor speed and the robot speed, adjusting the dynamic load balance, and many other things. One word of caution: if you're going to be working on a iRPickTool system, never underestimate the complexity of setting up the system. The setup can be very challenging. It has to be emphasized that you have to make sure that the encoder values are accurate. This is fundamental for everything else. Otherwise, your tracking frames are not going to be precise. The vision system can also have challenges. You can experience variances on the consistency of the product as you run, especially if you're working on the food industry. The product can change from batch to batch. It can change in color, also can change in shape. You might not have a consistent flow rate. You can have unexpected surges on the flow rate, and your system needs to be capable of handling such flow rate changes. For that, Fanuc recommends a 20% margin of safety when you configure your system and you're doing your simulations. That means your system needs to be capable of handling 20% more of the flow rate that you're expecting. That is in case you need to slow down the system when you do your final adjustment during production. Normally, this kind of systems is going to be running at very high speed, and one of the challenges is going to be the dynamics of the product, such as the inertia during picking and placing. You may have to put a special consideration to the design of your gripper, and if you are using suction cups, you need to have a reliable vacuum. For all of this, you have to be prepared and do a lot of simulation in advance to prove the capabilities of the system, and Fanuc offers iRPick Pro package as a tool for that. If you are more interested in learning iRPickTool, I highly recommend you to take a Fanuc training. Fanuc offers a 4-day iRPick Pro and iRPickTool training that is worth taking. Although it's impossible to cover everything in 4 days, they're going to show you the most important things that you need to know, and you're going to have a chance to have a hand-on experience setting up a Roboguide from scratch. The only caveat is that there are prerequisites. You need to take the HandlingTool training and the iRVision 2D training before you can enroll to this training. To wrap up, what I show you here on these videos is just the beginning. We're just scratching the surface of all the things that you can do with iRPickTool. You can configure the system in so many different ways. You can add trays, you can add buffering fixed stations, you can configure the Infeed and Outfeed conveyors with different layouts, you can configure pre-grouping, you can add recipes, you can expand your system to have up to 8 robots. So you can imagine there is enough material here to keep making many more videos. Okay friends, I'm gonna conclude with this video over here. I'm gonna leave the link to the workcell on the description below if you're interested in looking at that, and thank you for watching.